So this video kicks off our talk on the male reproductive system. Now the main goal of that system is just to create sperm and then deliver it. So if we look at the main players, we have your testicles, and that creates the sperm. And that sperm travels through things like your vas def and glands like your seminal vesicles, or more importantly your prostate gland. So we'll pretend there's a prostate gland. Will contribute some fluid to suspend the sperm, help it to swim, and then eventually all that will come out of the penis, and that's the way we deliver the sperm, to meet the egg and fertilize it. That's the general function of the male reproductive system, and that's what we're going to be talking about in the next coming videos. We're going to talk about the testes, the prostate glands, and the penis, so the main players. But before we do that, just want to go over some embryo, recap it. Hopefully you remember some of this is not all foreign to you. So we have our mesonephric duct, which contributes to the urinary tract system, but also eventually forms the male internal structures. So your mesonephric duct, and then cells of the mesonephric duct will form the indifferent gonads. And next to the mesonephric duct, you have your paramesonephric duct, and that forms your female structures. Remember? All that plugs into your cloaca. So hopefully that's not foreign to you, and that's just a quick recap. In males, you have your Y chromosome, and in your Y chromosome, you have your SRY gene that makes your SRY protein, which turns your gonads into testes. Do you remember the main things your testes make? They make anti-Mullerian hormone and inhibin. That degenerates the female reproductive structures. And then they make testosterone. That's your main male hormone, and that develops your internal structures. And testosterone has a lot of routes. We talked about it turning into estrogen via aromatase and turning into DHT via 5-alpha reductase, and that makes your external male structures. Good? That's just a quick rundown. Now here's an important thing. Your testes start up here. Do they stay there? No, they don't. They start to descend. And when we go into our embryology block, I'll talk about all the descension and stuff like that. But just know that they do descend, but because they start off way up here, and because they get their initial blood supply from the aorta, their lymph drainage is actually to the para-aortic nodes. Very important that you know that. So anytime there's something wrong with your testicles, if there's cancer, that's the main one, where would you see Mets to? In terms of lymph nodes, you see it in your para-aortic nodes. Trick question. Your scrotum, and also your penis, but your scrotum, which is the skin that surrounds your testes, don't drain to your para-aortic nodes. They drain to your inguinal nodes. Very important, you know that? It's a common trick question where I was thinking, all right, testicles come up here. Most students don't have any trouble remembering that testicles arise from near the aorta, so they drain to your para-aortic nodes. Many students are okay with that, but then they get a question on their scrotum, and they're so, I guess, focused about para-aortic nodes that they miss the boat. So your scrotum drains to your inguinal nodes. Your scrotum is basically your equivalent of the female labia majora, yeah? And so it's an outside skin fold. It's not gonna drain into near your aorta, it's an outside skin fold, so it's gonna drain to your outside inguinal nodes. As for the blood vessels, know the veins that carry back testicular blood. So in your right side, your gonad will have a gonadal vein, and from that gonadal vein, it will drain to your IVC because it's on the right side. Your IVC is on the right side, can go directly to it. Your left, on the other hand, will go to the gonadal vein. And it'll go and it'll go and it'll go and say, I gotta somehow transfer over to the right side to get to the IVC. I need to hitch a ride, and it hitches the ride on the left renal vein. From the left renal vein, it can go to the IVC. That's extra step's very important, because that extra step can predispose the left testicle to things like venous dilation. It can predispose it to if you have something wrong with your left kidney, like if you have renal carcinoma and it invades into the renal vein, then it can cause venous dilation of your left gonad. Yeah, because it's obstructing that blood return. That's just some general overview and anatomy. Let's talk a little bit more in depth about the testes. So this is what your testes create. I'm just going to erase anti-Mullerian hormone because after the embryonic period, it doesn't really play an important role. You still have inhibin just for negative feedback, so you don't make too much testosterone. But this is a general function of your testes. And in puberty, what controls puberty? GnRH, pulsatility. You start releasing a ton of FSH and LH. Not much different than in puberty of a gal. So we'll start with LH first. LH will stimulate cells called Leydig cells. And these are the cells that create testosterone. FSH, on the other hand, stimulates a cell called Sertoli cells. Easy to remember because there's an S in Sertoli, there's an S in FSH, there's an S in Sertoli. Easy to remember Leydig and LH because there's an L in LH and there's an L in Leydig. But jumping back to Sertoli cells are what creates the inhibin. And Sertoli cells are support cells. They create the sperm. And to create that sperm, they need a very tightly regulated, environment. They're like a diva Hollywood star that says, my dressing room needs a double-double from In-N-Out and 2 bottles of rosé, or I'm not going to perform, etc., etc. In the same vein, your Sertoli cells need XYZ, otherwise it's not going to perform, it's not going to create sperm. Okay, so some of these criteria, it comes together and forms a blood-testes barrier. Let's just say BTB for blood-testes barrier. This make sure outside exogenous things don't get into it, affect it. Now that's good in principle, but if there's a break in that blood-testes barrier, then you can have autoimmune attacks. Just a little side note, if a guy has infertility and you're studying his sperm for sperm analysis, you look for auto antibodies against your sperm because they're very isolated in that blood-testes barrier, and if somehow there's a break, you can have an autoimmune attack against your sperm. So this is just a side note, but it creates the blood-testes barrier. It is very temperature sensitive. It needs to have a very tightly regulated zone of temperature for which it can function and create sperm. Your Leydig cells don't care about temperature. They'll work whenever. And then lastly, they need a signal for it to create sperm, and that signal is high localized test. So high localized testosterone, and it does that by the creation of androgen binding protein. And the name gives it away, is a protein that binds testosterone, basically localizes it, keeps it close, keeps it tight, and that's the signal for sperm to get created. Now, how is sperm created? In your testes, you have these big tubes. And on the basement membrane, you have primordial germ cells. Yeah? Called spermatogonium. And men and women are very similar in the fact that we have a finite amount of germ cells. Women, when they run out of germ cells, they run out of follicles, they go into menopause, and they stop ovulating. Men, we also have a finite amount of germ cells. However, we can basically ejaculate until we die. How do we manage that? How can we get past the fact that we have a limited amount of germ cells? Well, your spermatogonium does something very clever. I'll write it down here. Your spermatogonium, which is a diploid, so 2N diploid, your spermatogonium doesn't initially go through meiosis. It's a germ cell that doesn't go through meiosis first. That's funny. Instead, it goes through mitosis. And so it creates exact replicas of itself. Nothing has split apart. It's exact replicas of itself. And one of them will go back to the basement membrane, and the other will continue on to make sperm. And that way it can replenish itself indefinitely. And that's how we get past that roadblock. Very clever way we can do that. So it goes through meiosis one first, and one goes back into the basement membrane, becomes a primordial germ cell again. The other one goes through the pathway of creating sperm. So this one we call the primary spermatocyte. We give it a special name. And the primary spermatocyte is now going to go through meiosis and split up. And so this diploid becomes a haploid. You need to know that it is this step that makes that haploid cell. Okay? So we call this a secondary spermatocyte. Again, very important for you to know that primary spermatocyte to secondary spermatocyte uses meiosis 1, and that's what turns your diploid into a haploid. And from that secondary spermatocyte, it goes through meiosis 2 to make your spermatids. Notice I said spermatids and not sperm, because these spermatids need to go through a maturation process. And in that maturation process, it starts to develop a head that contains the DNA, but also contains enzymes for it to penetrate the egg. We call those acrosomal enzymes. Acrosomal enzymes. There's also a midpiece, and that midpiece has a ton of mitochondria. It's going to need a lot of mitochondria and make ATP, because it's going to need to swim quite a distance. So I'm going to say ATP, mitochondria, that's the midpiece. And then lastly, you have a flagellum for it to swim. So the final structure of your sperm looks kind of like that. That is your sperm. Now that by itself is not good enough. We need a fluid to suspend it in, otherwise it won't be able to swim very far. Nor will it be able to travel out of the penis. So we need a fluid to suspend it in, and that fluid we just commonly call semen. And semen is made out of a lot of things, and it takes contributions from many glands. We talked about some, your seminal vesicles, your prostate gland. Well, your prostate gland contributes many things, some of which are in my notes, but one of the big ones is zinc. The exact function of zinc is not well understood, but it deals with viscosity, it deals with pH, and helps viability. They notice that if there's too much zinc or too little zinc, then the sperm isn't as viable. Your seminal vesicles, again, produce a lot of things, but one of the main things is fructose, is the fuel source, the sugar for your sperm. So I'll say fuel source. And you culminate all that together and you have semen, fluid to suspend the sperm, and that you can ejaculate, and that will make your sperm a little bit more viable, a little bit easier to swim to the egg to fertilize it in. Lastly, this is just kind of a random topic. I want to throw it in there, but if a patient is taking exogenous testosterone, we'll just say he's a bodybuilder or an athlete, or he's just taking steroids, how will that affect your fertility? Exogenous steroids, and any exogenous hormone, is gonna cause negative feedback. Your brain's gonna say, we have way too much testosterone, let's slow it down. So GnRH is gonna decrease. That decreases FSH and LH. And that decreases your Sertoli cells, your Leydig cells, and so you actually have in your testes decreased testosterone. A common side effect of exogenous testosterone use is testicular atrophy, yeah? From all this negative feedback. And because you have decreased testosterone, especially decreased localized testosterone, you actually have decreased infertility if you use exogenous testosterone. That does it for this video. See you next time.